Encapsulation explained. Beginner level. Introduction. In object-oriented programming, OOP, large programs are organized using classes and objects. To protect and manage data properly, programmers use a concept called encapsulation. Encapsulation helps control access to data and ensures that objects are used safely and correctly. Encapsulation is one of the four main principles of object-oriented programming. Encapsulation, inheritance, polymorphism, abstraction. What is encapsulation? Encapsulation is the process of combining data, variables, and methods, functions, into a single unit, a class, and restricting direct access to some of the data. In simple words, encapsulation equals hiding the internal details of an object and controlling how the data is accessed. Instead of accessing variables directly, we use methods to interact with the data. Why encapsulation is important? Encapsulation helps programmers protect data from accidental changes, control access to variables, improve code security, make programs more organized and maintainable. Without encapsulation, any part of the program could modify data incorrectly. Example without encapsulation. Consider a bank account example. Class bank account. Def__init__. Self. Balance. Self. Balance equals balance. Account equals bank account. 1000. Account. Balance equals -500. Print. Account. Balance. Output. -500. Problem. The balance became negative, which should not happen in a real bank account. This happens because the variable is public and unprotected. Example with encapsulation. Encapsulation solves this by restricting direct access. Example. Class bank account. Def__init__. Self. Balance. Self. __balance equals balance hash private variable. Def deposit. Self. Amount. Self. __balance plus equals amount. Def withdraw. Self. Amount. If amount less than equals self. __balance. Self. __balance equals amount. Else. Print. Insufficient funds. Def get_balance. Self. Return self. __balance. Account equals bank account. 1000. Account. Deposit. 500. Account. Withdraw. 300. Print. Account.get_balance. Output. 1200. Explanation. __balance is private. It cannot be modified directly. Data is controlled through methods like deposit and withdraw. This protects the object's data. Public versus private variables. Encapsulation uses access control. Public variables. Accessible from anywhere. Example. Self.name. Private variables. Hidden from outside the class. In Python, we use _____. Example. Self. ___balance. This prevents direct access. Getter and setter methods. Encapsulation often uses getter and setter methods. Getter. Used to read data. Example. Def get_balance. Self. Return self. __balance. Setter. Used to modify data safely. Example. Def set_balance. Self. Amount. If amount greater than 0. Self. __balance equals amount. This ensures invalid values cannot be assigned. Real-life analogy. Think of a capsule medicine. Inside the capsule, many chemicals are combined. You cannot access them directly. You only take the capsule as a whole. Similarly, encapsulation hides internal data and only exposes controlled ways to interact with it. Advantages of encapsulation. Checkmark protects sensitive data. Checkmark improves program security. Checkmark prevents accidental modification. Checkmark makes code easier to maintain. Checkmark allows controlled access to data. Disadvantages. Crossmark slightly more complex code. Crossmark requires additional methods. Getters, setters. However, the benefits greatly outweigh the disadvantages in real-world applications. Where encapsulation is used. Encapsulation is used in almost every modern software system, including banking systems, user login systems, e-commerce applications, mobile apps, game development. Example: user class, product class, bank account class, employee class. Each class protects its internal data using encapsulation. Simple definition. Encapsulation: the process of bundling data and methods together inside a class and restricting direct access to the data. Final summary. Encapsulation helps programmers checkmark protect important data. Checkmark control how data is accessed and modified. Checkmark improve code security. Checkmark build reliable and maintainable software. Without encapsulation, programs can easily break due to unexpected changes to data. With encapsulation, programs become secure, structured, and easier to manage.